So welcome everyone to our August Urban Updates. My name is Ellie Blaine. I'm the director of the Urban Soil Health Program, and we are kicking it off today with a technical topic from Jamie Bultmeyer, who's with A&L Labs as an agronomist and who has been our point of contact for the soil tests that our regional urban soil health specialists um, are taking soil samples on farm at our site visits for. And then we'll go into our statewide and regional updates and then kick it over to anyone else on this call who has other resources or updates that you would like to share from your region. And I think with that, I'll go ahead and kick it to you, Jamie, to share your screen.
Thank you, Ellie. Let me get that up and running. Oops, just a moment. And hopefully you see my title slide there, Ellie.
Yes, I do.
Perfect. Perfect. So, as mentioned, I am one of the agronomists with the A&L Great Lakes Laboratories in Fort Wayne, Indiana. There's actually 4 of us. And we all have our own specialties. We all have the fundamental rounding within the laboratory industry, but we have a soil scientist, we have a former fish and wildlife member, folks in production agriculture, and so we specialize in our areas, but we do a lot of generality type events like this. And so what I want to do today is sort of set us up for some good question and answer session here at the end of the presentation. But to do that, I want to walk through soil testing methodology. There's oftentimes confusion, lack of understanding, misunderstanding, misconceptions about how and what the data means and what we do with it. And so to start off, I want to give a very brief tour. And I apologize, I am a long-winded type individual. I like to talk. And usually when I do a lab tour in person here at the laboratory, it's about a 2-hour event. I'm going to do it in 6 to 7 minutes. We'll see how this goes. But my goal is not to necessarily make you an expert in the lab process, but just give you an overview of what we do at the laboratory. Sometimes it's a little misunderstood what we actually do and how those methods, the things we do at the laboratory, impact the results based on the material we're working with. Is it soil? Is it compost? Is it manure? Some things are very similar between those analytes and some things are very different. And that's what I want to focus on more so as we go through the presentation here today. So with all those pre-disclaimers out of the way, we'll get started in here. And so when we go to the laboratory, when a sample comes into the laboratory, it comes in through receiving. That can be through the front door at the laboratory. Somebody can come and say hi to Kelsey and drop it off at the front desk. Larger shipments go to the loading dock in the back. But regardless, it goes to the receiving department. And that gets processed and sorted. Is it a soil? Is it a plant? Is it manure? It gets routed to the correct location in the laboratory. And we start a process called layout. And that's where we open the boxes up, we open the bags, we open the containers, or maybe they're hand delivered, and we look at the paperwork. What does the customer want us to do? What tests are being requested? And we put them in a specific order. Some tests are held to the end because they're sort of specialty runs. Things are put in the front, and we line out and organize the sample run. Seems pretty simple until we get into our busy soil season and we start laying out 15, 16,000 samples a day. So it can be quite a project. But the goal is to get all those samples laid out so that we know which tests they are, we have them grouped together, and then we can start entering the information about them into the database. And so we want to try to get as much correct as possible. If there's any concerns, maybe a customer didn't fill something out correctly, or we're not sure what they want and we need to ask some questions, we do all that in the layout process. Because once the samples go into our drying system, it's a large room. We really need to have them in the correct order and know what we need to do with them. Some samples don't go into the dryer, but for a traditional soil sample like you would pull for a garden, urban farm, production farm, those are going to go into the drying system. And those samples are dried per specifications, and we'll get into that a little bit later, what those specifications are and how they're developed. But we cannot dry those soils over 104 degrees Fahrenheit, or we adjust the potassium levels. And so there's rules and guidelines. And again, like I said, we'll get into those in a moment, but there's rules and guidelines how to do it. But we're going to dry that sample. It can take upwards of 24 hours, depending on how wet the sample is, to get it dried. And we need to do that so that way we can process the sample accordingly. And by processing, I mean grind it. Most people think when you grind soils, you sort of think of the mortar and pestle concept, almost like a pharmacist or a herbalist type concept. That's not what we use. We actually use flail mills. They're swinging pieces of metal around a shaft, and they more explode the sample rather than grind it. But we need to work that soil sample into particles less than 2 millimeter, so that way the chemical test will act as predicted. They run correctly. Once a sample is prepared, it really goes through 3 processes in the lab. We're going to test it for organic matter, we're going to test it for nutrients, and we're going to test it for pH. And I'll show you what that process looks like in a moment. Once that's done, that's usually, so we lay out the sample in the morning, midday of the day it arrives. The next morning it gets ground and analyzed in that afternoon. We actually hold all that data till the following day, so 2 days after the sample arrived, because we want to look at the data all day long. We've got some known samples in there. We've got checks we want to look at. Did something bias a little higher in the morning than the afternoon? Is there something different about it during the day? And then once that's approved, it'll actually go through a couple of steps where my staff looks at it as well. Does it make sense for the region? And then we send this report out to the client. That could be an electronic data file to our large ag customers. That could be a PDF report to any of your staff. It could be a PDF report to the homeowner. And so that's sort of the big process, but let's get into the steps a little bit better. And I see a question came up in regards to the best time of year to take a sample. Let's hold on to that because I think we're gonna have some sampling questions during the Q&A. If we can make note of that one, we'll try to catch that in the Q&A. So what do these steps look like? So the first one is pH. We're going to scoop a sample. We take a known volume of soil and we put in each one of these cups. Those cups, there's 60 on a tray. This is lab specific and how the trays are organized, but the method isn't. So those cups of soil, there's 15 grams of soil. We're going to put 15 milliliters of water, and we're going to let that set and soak for 15 minutes. The thought there is you'll hear referenced as a 1-to-1 water pH. So it's 1 part soil, 1 part water, and we let that set for 15 minutes. We'll then agitate it, and we have some robotics to do that. We'll agitate it, and then take the pH of the slurry. And this is really a common concept across all of our analytes that are solid. So compost, solid manures, soils, growing mediums out of a greenhouse, there are going to be some type of water and material mixture that is used to create a slurry to take a pH. Liquid manures, liquid materials will take the pH of them as they are, but they have to be in liquid form to get a pH measurement. And so when it comes to the different testing you do, the pH is really quite consistent. You'll see some methodologies where they use salt pH, and that's out in the western regions where they have salt in the soil, and it helps adjust for biases caused by that. But again, that's something out west, and that's one thing you want to pay attention to when you read references about how you should interpret soil tests, how you should interpret and react to a particular number. Keep in mind where it came from. There is regional specificity to these numbers, and it's usually best to try to stay a little closer to home when it comes to those kind of levels of interpretation, unless you're really in depth into what those numbers mean and how they could potentially be different. So again, soil pH is a total, fairly consistent. Organic matter is probably the most simplistic thing we do. And again, very similar across a lot of the materials. We will take a known volume or scoop of material, and you'll see on the right side here, these crucibles. You'll put that known amount of soil, a weighed or measured amount of soil, into that crucible. I'm going to make this overly simplified because I don't want to get into all the details, but we're going to stabilize the weight. We're going to measure and weigh that. Then we're going to put it in that big blue oven. Surprisingly enough, they're Blue M ovens. And that oven's going to take and warm that sample up over a period of hours to 360 Celsius. And it's like burning leaves. It burns off the organic matter. We'll take that sample after a prescribed burn, cool it back off, and we'll weigh the sample again. The difference in weight is the percent of organic matter by weight. We call it loss on ignition. The temperature may vary with some of the analytes. Compost will run at some higher temperatures from time to time or lower depending on the method, but the same basic concept is done to determine organic matter. We're going to burn or ash off anything that's volatile or can burn and leave the mineral fraction behind, and we'll weigh that. The thing to keep in mind is that's a percent by weight. Organic matter is about 5 times lighter than mineral soil. So 1% organic matter is actually quite a large amount when you think about it on a weight basis. And so the next one is when we get into the nutrients. And this is where you will see a lot of variance in soils, as well as variance between the analytes. And this is where I'm going to spend some time, because the nutrient piece is really what differentiates a lot of the methodologies at the laboratory. So when we go to nutrients, again, we're going to scoop. Everything is a volumetric scoop. And we're going to put that volumetric scoop in a container. Ours happen to be, for lack of a better term, pill bottles or medication bottles in a styrofoam or a polymaterial block. And they get reused, so we will rinse them each time. We'll take that scoop of soil and we'll add 10 milliliters of Mehlich 3. That's our standard extracting solution. Again, this is where the details come in and vary. I'll talk about the differences, but there's multiple extracting solutions we can use. And that gives us different data, different values. And if you don't utilize interpretations that are calibrated to that extracting solution, you will get the wrong answer. And that's where a lot of people are challenged in all levels of soil testing. So we'll take that scoop, we'll add the acid, we'll put that acid or extracting solution in a shaker, and we will shake it for a preset period of time and a preset severity. If we shake it too long, we will get over extract, we will bias our numbers too high. If we shake it too hard, we will bias our numbers high. If we shake it too light or do it in too short of a period of time, we'll bias our numbers down. So this is very prescribed. Now, it's not like we have seconds to could cause these errors, but we only have a matter of minutes. So we need to start the process, complete it, and stop it so that we get a definitive reference of information. And to stop that, we take that soil acid solution and we pour it through filter paper. We basically separate the soil and the extracting solution. We will then measure the what's in the acid. A lot of people, when they think we're testing the soil for nutrients, actually we're not testing the soil. We're testing the acid. How much nutrient could the acid extract in the time they were in contact with each other? So we're really trying to find out what's extractable, and that extractable amount is not relative to any particular fraction. It's not directly related to what's plant available. It's not directly related to what the soil will release in a year. And that's the thing that's hard for people to maybe wrap their head around. It is an index. It is a measurement. And we'll get into more detail of it, but think of it here in the short term like a tape measure. An inch. We all know what an inch is. We can pretty well estimate if we had to hold our fingers up, an inch is about yay. We can pretty well tell that. So when we measure a board, it's 12 inches long. I can go to another board and measure out 12 inches, cut it, and know it'll fit. But in and itself, the inch is an arbitrary measurement. Same with these nutrients. If we don't have a relative reference to work with, the number really doesn't mean anything. 12 units of measurement. Is it a centimeter? Is it a foot? Is it an inch? It's irrelevant unless we know the rest of those details. And keep that in mind, that thought in mind as we continue on this conversation, this journey. So we'll actually use what's called ICP, inductively coupled plasma, and it will measure the nutrients in that acid. without any additional chemistry. It's really a cool technology. And this is what the technologies we're seeing in the lab industry go to. How do we get the answer with less steps and less materials? In the past, we used to have to put a color developing chemical with it, and it would turn color. The darker the color would be, the higher the concentration. Well, that was an extra chemical. That's another chemical to dispose of. In this situation, we're using very weak organic acids, acetic acids, and those kind of things, very common acids that are not heavy metalled. They're not hazardous waste. And when we put their ICP, there's no additional chemistry added. So the ICP, it takes a small amount of that liquid, puts it through an injection nozzle, and sprays it into a plasma flame, or 500 degree Kelvin temperature of the sun type stuff. And that breaks the elements down, the molecule, the compounds down to their individual elements, and they make them glow. Each element has its own wavelength of light it gives off, and the brighter the light is, the higher the concentration. It's quite simple. And with the malic 3 acid that we are using, we can collect all the nutrients in one step. If we went back 20 years ago, we would actually have to scoop that sample 5 times to get all the nutrient data. We can now do it in one. A 300% increase in productivity makes a huge difference. And that's where we're seeing lab changes. When folks ask me, well, what's the new things in lab? Where's lab technology moving? It's like a lot of the industry around us. How can we get to the same result in fewer steps with less inputs? And so that's how we are able to run 15, 16,000 soil samples a day, is because of automation and these flow-through processes. So let's change gears a little bit and let's get a little deeper into what the numbers mean, how these methods and the things we do at the laboratory. Trust me, there's a lot more detail in those steps, but I want to keep it short in the nature of the conversation because this is the aspect of it we need to pay attention to today. Again, organic matter and pHs are totals. Those are absolutes. Those are calculatable numbers, and they're fairly similar across organic materials such as compost, soils, manures. The processes and numbers are relatively the same. When we get into the nutrients, that's when things change. So when we're looking at soils, we're looking at extractable nutrients. Again, it's no particular range of nutrients. It's what the acid could pull out. So we are picking up the nutrients that are in the soil solution, the liquid fraction of the soil, what the plants are taking up through the roots. We are measuring that. For cations, we're easily pulling out those nutrients that are held by the cation exchange capacity. Cation exchange capacity is the fact that soils have a net negative charge, predominantly from clay and organic matter molecules, and they hold on to positively charged cations. Calcium, magnesium are the two predominants. Potassium, magnesium, calcium, manganese, zinc, copper. It's a positive and negative charge, opposites attract, same as magnets. So we are pulling that, and we're getting a small fraction of the mineral. And we'll talk a little bit more about the mineral. But the stronger acid we use, the more of this mineral fraction we get, and that's where the data differs. I keep coming back to this concept of extracting acid. There are multiples. And that's where folks oftentimes get caught, is they will use interpretations for acid A, but the lab used acid B, and the numbers and the interpretations don't line up. And they are measured as a concentration. This is a minor note, but you'll see sometimes a soil test come back in pounds per acre. That is a concentration. That is not an absolute. You cannot think of the thought of, okay, I have 30 pounds per acre of phosphorus. The crop will move 20, so I have 10 extra. It doesn't work that way. What it is it's actually a part per million measurement. Is a concentration, parts of nutrient per million acid. When we look at the pounds per acre concept, this is some legacy from back in the 30s and 40s of last century, which gives us an idea of how long some of this stuff hangs around. The easiest way to explain this is there's a stat that if I use an old school moldboard plow and I turn the soil over, 1 acre of soil in that plow furrow slice will weigh approximately 2 million pounds. And that's a very, very wide rule of thumb. That can vary by 20%, but it's 2 million pounds. So when I have 1 pound of nutrient per 2 million pounds of product, it's basically 2 parts in 2 million. We take that number, divide it in 2, and we get parts per million. So when we at the laboratory measure something, everything's in parts per million. So if it comes back at, say, 15 parts per million phosphorus, and somebody wants it reported in pounds per acre, we just multiply it by 2. It's an arbitrary number that hangs around in the marketplace. But keep in mind, please, it is a concentration. It is not an absolute. You can't do math on that. Well, the crop needs X amount of pounds, and the soil test I have has this. It doesn't work that way. And that's a very common misconception. It seems like it should, unless you know otherwise. So when we go to, and that's how we do a soil. So when we go to a compost, we actually do a complete digestion. We take that compost, we put it in acid again, and we put it in microwave, industrial, under pressure, and we digest that compost all the way down to its core elements. It will be liquid. There'll be just a couple flakes of material when we're done. And we measure that acid. In that case, it is a total amount of, say, phosphorus or potassium in the compost. We do the same with manures. Those are totals. Soil, we're only extracting maybe 3 to 5% of the total amount of that mineral. So we're still trying to get a mimic of what plants access, but it's not everything. We're only playing with a fraction. So when we try to use a a compost as a soil and a soil as a compost, we're getting very different numbers. And we'll talk a little bit more of that as we go through. As we move on down our soil test, we'll get into cation exchange capacity, base or cation saturation. Those are calculations. Those are mathematical adjustments based on the actual soil test numbers. Those are usually referred to as summaries or estimates. There are lab methodologies to get definitive numbers, but they cost $50 to $150 per sample. They're impractical. We can get within a couple of percent accuracy with a calculation, unless something is really unusual or something's really out of whack. We just use the calculations. It's more cost effective long run. I won't get into researchers and engineers and those kind of folks that'll want to use absolute numbers, but we try to avoid those things in production ag. It just doesn't make sense. So let's get into the theory a little bit more, and that's where we'll slowly dive into this and get a little more clarification. So again, when we're looking at a soil test, specifically nutrients, we have a continuum. We have nutrients in the soil solution that are plant available. I can extract the soil with water and get that material. And there is, if we do a saturated media test, that's what you use for non-soil materials in a greenhouse. It's what it is. It's a water extraction. We pull out what's in the water. In a greenhouse media, there's usually no ability to hold on to nutrients, so we can get it all with water. In the soil, we're going to get a very small fraction. So we got a continuum from water to rock. And the stronger the acid we use, the further up that continuum we go. So we use weak acid, we get a little bit of that continuum, and as we get stronger and stronger acid, we get further up, we get higher numbers. We get a bigger fraction of that mineral in that soil sample. Seems like a lot of hocus pocus, I know. But there's a reason that works. So think about this. Let's get it into a real world situation. Probably within the last day or two, you drove a vehicle. The vehicle has a gas gauge. You may not know a dang thing about that car or truck, but you need to drive it somewhere. So you look at the gas gauge, fuel gauge when you get in. The fuel gauge says the fuel tank is half full. Okay, that's nice to know. But if I don't know anything else about that vehicle, that information is really not very useful. It's of very little value. So I have half a tank. So what? But if I know the tank holds 20 gallons of fuel, well, half tank means I've got 10 gallons. Now I have some information. And this interpretative information around that number is where the value to the number becomes. So the half full fuel tank means nothing until we know the capacity of the tank. Okay, we have 10 gallons. because it's half a 20-gallon tank. My vehicle, and I'm going to use very simple numbers because I'm not, I don't do well with math on the fly. So say the vehicle gets 10 miles a gallon. That means we can drive 100 miles until we're out of gas or fuel. With more information, say we know that our destination is 120 miles away. Now we know we have to stop for gas, and we have to fill it up before we're going to make it to our destination. Or if it's the destination's 80 miles away and I'm running late, I can get there and I'll just pick up some fuel first thing after I'm done with my appointment. So now we have this interpretive data around that vehicle that makes a half full tank gauge, at half tank gauge, meaningful. Now we can make decisions, we can predict, we can estimate what we need to do, we can even figure out how much gas it's going to cost for gas. We now can make a lot of good decisions if we have this interpretive or understanding data around it. The same thing with a soil test. So I mentioned Mehlich 3 multiple times. That is sort of evolving as the universal industry extractant. It is called the universal extractant because it pulls out all the nutrients. But we know from research at university, from industry, that if I have a soil test level below a particular number, there's a good likelihood I'm going to get a response to fertilizer. If I'm above that given number, the response potential for fertilizer is very low. We also know through research that if that number is up over 80 to 100 part per million for phosphorus, for example, we can leach it. It can actually be so high enough that the soil can't hold on to it. It can actually leave the soil profile. And so these interpretation, this understanding, this research takes a arbitrary acid extraction number and gives it meaning. And so the nutrients in a soil are completely arbitrary. They are an index, but when we apply it to known data, now that index has meaning. But as you can imagine, if we use a weaker acid, say Bray, which is the traditional that has been used in the university realms and in public areas prior to Mehlich 3, those numbers are 20% lower. Well, if I put it in, try to use an interpretive chart, I have to use one specifically for Bray. If I cross over, that 20% difference in data value will potentially skew my nutrient application by 20%. And there's economic and environmental impacts to those things. So be very cautious when you look at fertilizer charts to say, if your soil test is X, apply Y. Make sure that the soil test methodology, predominantly the acid used to get the number, matches the interpretations. Because if they don't, you're going to be all over the place. And so I can't stress that enough. The good thing is it's not just the Wild West. There's only a handful you're normally going to run into. Now, if you look across the country, there's more than I'm going to reference. But again, if you've got questions, ask somebody familiar with soil testing, and we can help you with this. So what we do at the laboratory, we're not certified. There isn't like a government agency that oversees us. We completely voluntarily regulate ourselves, and it actually works quite well. So there's twofold ways we do that. First off is called the Method Region books. So I'm going to share with you, American Soil Science Society of America, AASA, has put out this lovely book. I think 95 is the last version of it. This is part 5. There's 7 books in the series. This one's for chemical extractions. And what's nice about that book is if I want to know how to test for carbon, all the test methods for carbon are in that book, and it tells me where they work well and where they don't. What these regions are that you see on the screen, these are different areas of the country where university staff members, soil science specialists, got together and said, based on all the processes in this book and where they work well and where they don't, which ones make sense for our region. So the first one on the left is the recommended chemical soil test procedures for the North Central region. That's us here in the Midwest. But there's roughly 5 regions in the US, 5 or 6, I have to look. But each region has specified which ones out of that book work best. So in our region, we're going to use organic matter by loss of ignition for soils. We're going to use a 1-to-1 water pH. There is a buffer pH, and that's another conversation we won't get into today, but that helps us determine how much lime to use. There's a specified method for that that works well in the region. And when it comes to nutrients, you will see that it's going to be what we call NCR, which I'll show you the listing in a moment, are the older school methodologies, or Mehlich 3. And the reason I say listing, Mehlich 3 gets me all my nutrients in one shot. The older style takes 5, so it is a group or a list of methods. And Mehlich 3 is becoming pretty standardized throughout the US. The Southeast US, you'll see in the middle there, they use Mehlich 1, an older version. And that's the only place Mehlich 3 really doesn't work well, in their coastal soils. But outside of that area, Mehlich 3 is the standard. And we actually measure in Mehlich 3, but we'll report either in Mehlich 3 or that NCR grouping. And again, I'll show you what that list looks like here in a moment. But when you change that acid that's used, you change the data, you change the interpretations. So we get into the different nutrients. So phosphorus in our region can be measured by BRAP1, BRAP2. Those are the older acids that were developed in the 30s and 40s. Mehlich 3, that came in the 70s and 80s. Nothing in soil science moves very quickly. But there's also what's called a bicarb, and this is used very sparingly in our region. We sometimes run into soils with very high pH, and it will neutralize our acids. So if the acid is neutralized, it doesn't work real well. So at a very high pH, sometimes we'll lean on what's called Olsen. It's a noticeably different method. But potassium, our NCR method is ammonium acetate extracted. But we can also do Mehlich 3, pardon me. Calcium, magnesium, sulfur, ammonium acetate is a standard NCR method, or we can use Mehlich 3. Micronutrients. The NCR is hydrochloric acid and hot water for boron. DTPA is used some in the West, or Mehlich 3. If you notice Mehlich 3 shows up on all these, that's the reason we use it. It's pretty well standard in the industry and allows us to do everything in one step. That's why we can keep our costs down on soil sampling methodologies and make it more affordable to the marketplace. So here's where how the methods are different. Now this is a list of all the methods. This is the master list out of the book and one or two extras. And I want you to see how the numbers vary. So if I took a given soil sample, any standardized soil sample, just one, and I ran it through all of these different methods, what would the answer look like? What would the resulting data come out? So if I did a water extraction, I just simply pulled out what was in that soil solution, and I use phosphorus as an example. In this particular sample that I'm thinking of, you would be about 0.2 parts per million, almost undetectable. And that's the challenge with water extraction, is the numbers are so small, they may range from 0.1 to 0.3 on the extreme ranges of high to low. It doesn't give us a lot of specificity or differences. Now, if we put that water extraction into maybe greenhouse media, it could be 10 to 100 fold higher. So we'll start there. So again, we're working up this continuum. These acids are going further away from the glass of water into the rock. Olsen or bicarb, that one that works better at high pHs, it might give us a result of 7. So we see some pretty big differences. If I use a bicarb interpretation on water data, it's going to go horribly wrong. Mehlich 1, I mentioned before, it would come back about a 17 part per million. So almost 3-fold higher. It's a stronger acid. H3A is a new one coming in like the Haney Soil Health Test. It might come back at 21. So it's actually a stronger acetic and citric acid. For AP1, but I'm going to measure it colorimetrically. I'm going to do the color development method, the old school. It come in at 24. But I'm going to rerun that Bray through my ICP here at the lab. Now it's 25. Pretty close, but a little different. I'm going to use my Mehlich 3 and do it color. Comes in about the same. Yeah, we'll do Mehlich 3 ICP. We'll just freshen up with another method. Now it comes in about 4 part per million higher, but we're just getting this constant range. Unfortunately, we're not done. There's more ways to do phosphorus. Bray P2. It could be anywhere from 25 to 100 part per million soil test result. And here's the real kicker, is total. In that same soil sample, we might have as much as 5 to 6,000 or as low as 500 part per million. So if I were to use any one of these methods in the wrong interpretation chart, I could get wildly different answers. The second part is again, this is an index. So the Mehlich 3 ICP we use most of the time, that 30 part per million answer is what we got. But that again is, if you look at our total, it could be up to 6,000. We're only working with a very small 1 to 2% fraction of the total out there. So I'm gonna look at different methods. Remember I mentioned compost, manures, and tissues and some of those other things. Those are totals. So if I ran a soil through a compost method, I would get an answer of somewhere in the multi-thousands. If the acid can digest the soil minerals to that point, which probably isn't possible, but I could get a number wildly higher than if I ran it through a soil method. And so it's really important when I'm testing a soil that it be soil. When I'm testing compost, that it be compost. If I get into blends that are 50-50 or 1/3, 3 items, the testing methodology really doesn't necessarily support those situations very well. One button too quick. So not going to dwell on the numbers, but here's the two lists. So Mehlich 3 is on the left. That's the standard. We've been talking about the universal extractant. The middle column, that's at NCR. Those are the methods that would be used to get all those nutrients if we used what we call those NCR methods in the book, that NCR grouping. We can report either of these at the lab. Always look, and we will tell you specifically. If it says M3, it's Mehlich 3. If it says Bray, it's a column in the middle. We use internal calculations to go from Mehlich 3 to that middle column, and there's a rough number if you would be interested, but they're going to be somewhere between 30 and 0% difference. So some of them are actually identical between the two methods. So I've been talking about this a little bit, but I want to get into it very specifically. A soil test uses a weak acid to dissolve and extract minerals. It's acid extractable. That does not have a direct relationship to any plant fraction or fraction in the soil. It's just what did that acid pull out. But it is only a fraction, maybe 1 to 5% of the total amount of that nutrient in the sample. I go to a saturated media test like we use for a greenhouse. That material, if it is truly greenhouse material like vermiculite, perlite, it has no nutrient holding capacity. There is no mineral composition of that sample. So there's no reason to use an acid. All the nutrients are readily available and can be extracted with water. So a saturated media test for a greenhouse material is for water. Now, if I'm using a hoop house or a greenhouse with actual soil, I don't want to use that test. I want to use a soil test. Test needs to match the material you're actually testing. And with a compost, we're doing a complete digestion. We're dissolving it to its core. It is a total. And those interpretations and the material and the test all need to match. So what happens if I do things wrong? So if I test a soil with a soil test, I'm going to get a good number. If I test greenhouse media with a soil test, I don't know what I'm going to get. I will get the water extractable, it's the same as if I test it as a greenhouse material. But it depends what that neutral media is made of. If that vermiculite, cocoa fiber, whatever that material may be, if it has some elemental content that I can dissolve with an acid, I may bias the sample upward. I don't know, probably not likely, but don't push our luck. If I do a soil test on a compost, I'm going to get bad numbers. So if I use a manure-based compost, I will greatly overestimate the nutrient content. The numbers will go much higher. If it's a plant-based or more ash-based compost, I will underestimate the nutrient capacity in current interpretations. Either which way, it's not going to work. If I do a saturated media test on the soil, I'm going to miss all of the things on the cation exchange capacity, the mineral that's going to dissolve in the next year or two. I miss all of that. I only get what's in the water-soluble fraction. And if I do a saturated media test on the compost, there's very little nutrient in the liquid fraction of compost other than potassium. Most everything is in the organic fraction. It needs to break down over time. It needs to decompose. And I will underestimate. If I do a compost test on a soil, I will greatly overestimate because I'm going to get pretty harsh on how much of that soil I try to dissolve in my acid microwave bath. So, and if I, again, same thing, I'm going to overestimate because those are totals. That's a really aggressive digestion. So I'm pretty confident that if you use a soil test on anything but soil, you're going to get a bad number. And I know sometimes we run into scenarios where we're 50% compost, 50% soil, and the question is, what do I do? First off, I would probably encourage you not to go into those scenarios. When you're over 10 to 15% organic matter by content, by weight, it changes the chemistry, and we can actually run in the physical properties. It can actually be a detriment, even though it might seem like very nice tilthy soil when I hold it in my hand. From a growing and a science perspective, I really don't want that material. So if we can avoid the material in the first place, if it's 10 to 20% compost and 80% soil, run it as a soil. We're going to be a little off, but we're going to be pretty close. To really try to avoid those even mixes. And if we're doing a compost type raised bed, you're going to test it as a compost, but understand that's only going to tell me what is that compost is going to release while it decomposes. It doesn't necessarily give me fertilizer recommendations or nutrient recommendations. So we really need to use the test tied to the medium and for the purpose we anticipate. And that's why I know the urban soil health staff are here to help. That's why there's an agronomy staff, there's extension office extension agents, there's soil and water conservation staff. There's many folks out there to help you work through this if you have questions. And with that, I know that was a pile of stuff to go through. I know there has to be questions. So I'm going to quit sharing and see what those questions are. And I think we had one in the chat to start with anyways, if I can get that chat to pull back up. I'm going to start here. There's one from Megan. Is there a best time of the year or most telling season to collect soil samples for growers, or does it depend more on the crop soil management strategy? Great question, Megan. Soil samples will, and the soil test results will change all year long. Potassium has a tendency to be higher during periods of extended moisture and lower during dry periods. pH during drought can actually go down. And so, yes, time of year will have an impact. And also, too, you think about during the fall that the crop or the plants you're growing have been drawing on that soil reserve, and it has been declined. You'll tend to see the lowest numbers near harvest. And then once you go after harvest, the plant starts decomposing and the nutrients are cycled back to the soil. The reality of it is it doesn't vary that much throughout the year in most cases. Potassium will get a little noisy, but the rest of the nutrients are pretty stable. I would argue collect the sample when you can do a good sample. You can get good proper depth, proper numbers is more important than the time of year. But the key is I encourage you to be consistent. If you pull your samples in the spring on any given year, always pull them in the spring. If you pull them right at harvest, always pull them at harvest. If you pull them post-harvest, always pull them at post-harvest. What that allows you to do is compare data over different scenarios and learn more. If you start changing the time of year and the situation, you don't know which impact is causing the numbers to change. So again, you're only looking at maybe, in worst case scenario, maybe a 15% difference in numbers. Usually it's 5 or 10. It's insignificant. Sampling error can be greater than the error you see at what time of the year you pull the sample. Logistics work best. I encourage large farmers pull their samples a season in advance. If I'm going to spread fertilizer or nutrients or compost in the fall, pull the samples in the spring. If I'm going to put my nutrients on in the spring, pull the samples in the fall. Give yourself a couple months to look at the data, figure out a game plan, purchase products, pull the logistics together. The little bit of error in the test will be far overcome by the benefit of being able to do a better job managing it. So let me look at chat and see if any other questions come up here. I'm glad that the pounds per acre versus ppm worked out. Thanks, Carla, for the comment. So is it the same across the industry that if the soil test results are imported in pounds per acre, someone can just divide by 2 to get parts per million? The answer is yes. from a laboratory perspective. You will find some consultants, some growers out there that will try to adjust. Well, I took an 8-inch sample, so I need to adjust that number because the assumption is 6 2/3 inches. I can't just use 2. I have to use a number slightly different. You're overthinking it. Quite the industry standard in the books that I shared with you is a multiplication and division by 2. My encouragement in the marketplace is just simply use the raw parts per million data and avoid the conversion. The nice thing with Mehlich 3, we avoid conversions. The less conversions in math we do, the less chances for biasing and error there are. So let's stick with raw part per million Mehlich 3, and we don't have any conversions to concern ourselves with in most cases. So I see a question here. What's your recommendation then for analysis and interpretations of a 50-50 compost and soil blend? We talked about that a little bit already. There really isn't a good option. If it is a plant-based compost that you're using, a soil test is going to be impacted very little. If it is a manure-based or a very fresh-based compost, you're going to overestimate the nutrient availability and underestimate the supplying power long-term of that nutrient. There really isn't a good option to test in those environments. That's more going to be a situation where a soil test will help you identify gross errors, but it won't allow you to dial in. The pH would be fairly accurate, the organic matter would be accurate, but when it comes to nutrients, all you can do is avoid excessive levels or basements. It's going to give you guardrails at most. We're really not going to get a lot of useful data. You're doing a soil test, a compost test, or a saturated media test on a 50-50 compost soil blend. One last question here from Megan. Because many of our growers are utilizing a variety of growing mediums, soils, leaf compost, and manures, what is the definition of a compost according to ANO? And so a compost is going to be decomposed organic materials. Soil is something that is naturally built by the environment over centuries. True soils take multiple centuries to develop. If it isn't native soil that has been developed over centuries, most likely it is a compost-based material that has been augmented or a greenhouse media. So compost is going to be anything that was very valuable material, but it's going to be anything that's generated from the decomposition of organic materials. And so another question, a good one. What is the difference between a normal soil test and a lawn and garden? That is an important one. Predominantly it's cost, but it's also going to tie into what you get back in return. So I'm going to stop my share. Stop sharing. I'm going to share something else if I can find it here on the fly. There it is. So bring this up so I can see it a little bit better. You should be seeing an ANO Great Lakes lawn and garden soil test. And so there's how this is done, just for those who may not be familiar. When you send in a soil sample, we request that you send in a submission form. That submission form is basically our instruction sheet. What do you want us to do? What test do you want us to perform? And who is it for? And so on the submission form, it will drive which one of these tests you get. If you send in our standard or routine soil form, you're going to get, so I can make this just the right size, you're going to basically get this data up top. That is the results of the soil test, what your organic matter, what the nutrients are. This is the data from the test we perform, no interpretations. If you use that standard report and say, I want you to provide me nutrient recommendations for a lawn, it costs an additional $1, and then we give you this next segment. Now, some forms may look a little different, but it'll be the same information. The next form here is annual nutrient requirements. How much nitrogen, phosphorus, potassium, the basic nutrients. Now, if we didn't test for sulfur, we can't give you a sulfur recommendation, but we'll give you recommendations on those nutrients we tested for to raise a good lawn. In this case, it happens to be, I know this one happens to be a vegetable garden. So here's the nutrients to raise that vegetable garden. You still have to figure out how much fertilizer to apply or nutrient to apply and what products to use. Do I use compost? Do I need elemental sulfur? Do I need triple 12? All that's up to you or your suppliers. And this is the most cost-effective option because this is something we do completely through the database. And I should also note that you see here it says Bray P1 equivalent. That is NCR, so that's Bray, phosphorus, ammonium acetate. This is not Mehlich 3. And not all labs, and even ourselves, we're guilty of. We don't always 100% specify the method. If you got a question, call the lab. They can answer that question very quickly. So this is a standard soil test. The lawn and garden brings this into play. When you do a lawn and garden, you use a lawn and garden form. That lawn and garden form triggers in our system the addition of individual recommendations and an additional cost. So if we do just a soil test with nutrient recommendations, we're at $9.75 list price. For a basic, we're at $20 for a complete. That means we add micros. If we go to a lawn and garden, a basic lawn and garden is $25. A complete with micros is $35. Big cost difference. The reason is one of the agronomist staff here at the laboratory, usually David, but David, I, or Don, are going to sit down and we're going to look at their soil test results and we're going to say, we recommend using these commercial fertilizers. We get into organic materials. We don't know what the test levels are. So we can only make comments on commercials that are guaranteed. So we'll say, in this situation, these are the best fertilizers we can recommend you to use, how much of that you should use, how you should use it, when you should use it, and what ramifications might come up if you do it wrong. Those are all done here at my office. We do some cut and paste, but those are custom built recommendations for that report, and that's why it costs more. So I just always want to justify why we're charging $35 for a complete versus $20. We basically charge $10 to sit down for the 10 to 15 minutes it takes to write these out. And it can be an all-day project for one of our staff members during the busy season. So again, this is a soil test, is the analysis results, nutrient analysis and the results, and nutrient requirement. These two segments is a basic soil test with recommendations. Lawn and garden brings in the rest of the enchilada. So let me quit sharing that, see if any more questions popped up. Oh, did I lose that share? Stop share. And let me see. Oh, another question coming in. Could you discuss soluble salts, EC measurements, and how methods might differ for soil, compost, and greenhouse media? So EC, electrical conductivity, is a test that actually is done is like pH. It's done very uniformly across all the materials. So compost, soils, greenhouse media. What we're doing is we're measuring for soluble salts, and a salt is anything that is a positive and negative cation, positive and negative elements like potassium chloride, potash. It's potassium positively charged, chloride negative, that are held together by the positive and negative attraction, but they dissolve in water. And commercial fertilizers really are designed to be salts, so they do dissolve. And when they're dissolved, they're 100% plant available, so they become available very quickly. They're sort of almost a rescue compared to like a compost that you have to wait for decomposition to get that release. So when you look at electrical conductivity, we're measuring the soil's ability to conduct electricity. The more solutes, the more salts, the more of those individual cations and anions, the higher the conductivity is. What that tells us is, regardless of the medium, plants can only tolerate a certain level of salt. And the higher that number gets, the greater the chances that you're going to have root damage because of it. Usually in native soils, we don't have that issue in our region because we get a lot of rainfall. But in a hoop house where you don't get saturating rains, or a greenhouse, it is a real issue. We also see it a lot with salt melts around sidewalks, driveways, and drainage ways away from parking lots. When we get drainage away from those hard surfaces in the early spring, when they use de-icer in the winter, we can see elevated levels that can actually damage, hinder, or even outright kill plants. So the EC measurement is very consistent in methodology across all the materials. And another question came in from Vigo County. We got just a few minutes here. My soil interpretation looks different from the one you just posted. Can I get mine changed to that format? So yes, so if you're doing a lawn and garden test with A&L Great Lakes, that's the format you're going to get. You're going to see that exact one. If you're doing just a soil test, we actually have, I think, 140 different versions. Some people want to see tables, some people want to see stats, some people want to see graphic charts. We do, and if you wouldn't mind sending the lab an email, we can definitely get the default for your account set up to, we have a version of that in our standard. It does not give you the lawn and garden information, but it would give you the top half of that report. And if that's something that works better for you and you like it from a visual standpoint, we can provide that. Again, just send an email to the lab or myself. My email is, I can put it in the chat here in a moment, but it's Jamie, Jamie, my first name, and the last name B is for Boltzmeyer, at algreatlakes.com. And I'll put it in the chat here. If you want, I can look up your account and make that change for you as well. Any more questions in chat? I think I got them all, Ellie. Did I miss one? I'm doing better than normal. Usually I struggle with chat, but it seems to be working well today.
I think you got them all. Thank you so much, Jamie. That was very informative.
I apologize. I know it was tough. I feel like I was going into some nooks and crannies every now and then. I apologize. I hope I didn't lose anybody. But I wanted to give you the understanding as to why, other than just giving you an answer. I like people to understand the why more than just the answer, maybe.
Yeah, and the whole, like, being able to see, like, behind the scenes of what goes on in the lab helps understand, you know, what even is Malick tree, because, you know, hearing just that is not as real as, like, seeing what it is and how it fits into the big picture. So thank you so much.
And I'm
so
going
to... Go ahead, sorry.
See, Ellie put it up there for me. I'm just going to say, if other questions come up, feel free to drop me an email, and I will gladly address them.
All right. Well, so Ellie indicated here that we will also send out the slides that Jamie created for the call. But if there are any other questions, then we'll just move on to what's next in the call, which is the regional updates. Next slide, please. So I'll start with myself. I'm Marian Rodriguez. I'm the Northwest Urban Soil Health Specialist. And here in the past month, I just focused on doing a little bit of outreach. I participated in the Wabash River Fest in Tippecanoe County with a booth and got to distribute some cover crop seeds, which I still have some. So if you're interested in, if you have events coming on and want to distribute your own cover crop seed, feel free to reach out to me. Also participated in a Family Matters event with Benton County SWCD and other partners in the area to share about conservation careers and to a group of inner city kids from Chicago. I'm also been providing working group support, administrative, and providing technical assistance. And then I've also been helping plan the Get There conference that's coming up this fall in October, and we'll share more information about that later in this call. And then I'm also working on an infographic about conservation practices. So that's some of the things that I've been working on. And next we will have Ellie, who will share Terry's update from the Northeast. Oh, sorry, before I continue, we also are hosting a cover crop and motion calculators webinar series out in Northern Indiana, but it is open to anyone statewide that would like to attend the training as well. the first day is August 19 and the second day is August 29. And then we will be hosting one in October for the nutrient management calculator. So we'll share more information about that one later. But yeah, now officially that's all I got. And then we'll have Ellie share about from Terry.
Thank you so much. So I'm pretending to be Terry for today, and she wrote out her update here. So July and the beginning of August have been fun and fulfilling. Please enjoy my updates as I'm currently in Wisconsin visiting with family and no doubt enjoying some cheese, a brat, and possibly even a beer. There have been many farm visits across the Northeast region. Getting out and talking to the farmers has been so inspiring. I'm grateful for them for taking the time out of their busy season to chat about their conservation and soil health practices with me, including cover crops, Spy the Farmer inspecting his buckwheat in the picture in the upper left. I really enjoy when the SWCD and NRCS folks can come with us for these walkabouts as their schedules allow. So thank you for those on the call that may have been out in the field with Terry, and feel free to reach out. One farm that was particularly eye-opening for me was a visit with a mint farm on invite from Chris Mathis, who's the supervisor with St. Joe County SWCD. It was remarkable to see the farming operation, including the harvesting and distilling of the mint. Upper middle shows the still, and it was neat to learn that they harvest the mint directly into the bins, the big red containers in the picture on the upper right. And these are set up to attach the steam and extractors to directly. It is an effective system. The fragrance was intoxicating. I learned a lot about mint flavoring that goes into our food and health products. And we don't often think about Indiana as a huge mint producer, but up northeast, there's a ton of mint producers, and it's a big product for our state. We had 2 events this past month. The Soil Health on the Small Farm with Kosciuszko County Soil Working Group was so much fun. We gathered at Hawkins Family Farm to enjoy wood-fired pizza, snuck in a quick slump test demo, and were treated to a sunset farm tour by Jeff and Zach Hawkins. You can see the large crowd in the bottom left picture with Zach talking in front of one of his high tunnels. As usual, it was downright magical and so neat to learn about all the soil health practices they use on their farm. If you have a chance to get out there, I would 10 out of 10 recommend it. And that is in Wabash County, Indiana. The second event was the High Tunnel Build and Learn in Rochester at Russ and Lois Mann's home. Lois Mann is with CCSI. And we did some quick planning because Nifty Hoops originally said it would be 6 to 8 weeks and came back with a date in 2 weeks. So they ran with it, and when the day came, they built a high tunnel in 1 day with people from the community, and that is one of Nifty Hoop's community build days. And this was a EQIP-funded high tunnel, or supported high tunnel. SWCD, NRCS, and aspiring high tunnel growers also joined. The only thing we couldn't do was put the final plastic layer on top as the wind gusts were too strong. They came back the next morning to finish the job. Lastly, I got to travel to Detroit for the first National Urban Ag Conference by the USDA. It was my first time visiting Detroit, and I love diving into the long and strong history of urban ag in the city. We went on farm tours, learned from industry leaders, and networked like crazy. I was presently surprised to see so many farmers representing at this event. The diversity in speakers, topics, and attendees was awesome, and I'm looking forward to seeing what they do in future for this event. It was well done. Thanks to everyone I've crossed paths with to help make this month so gosh darn fun. And yeah, plug for the Urban Ag Conference again. This was the first one, so we wanted to send a representative and see what it was like. And wonderful that it was so valuable, and really encourage others in the future who can attend. All right, thank you for your time. I
Thank you,
am not.
Ellie. Now we'll have Casey in the Southwest. Oh, is she here? She's not here, right? I'm sorry.
Yeah, I meant to double check. She had a flat tire this morning and was running behind. So, with Casey with the Southwest, her highlights have been the Pathway to Water Quality State Fair in and making some improvements to the urban area. She has had a few volunteer days there and then has worked with a national design person with NRCS for adding 2 signs to the Pathway to Water Quality, one on composting. We've started to build a display on composting there that will match with changes that NRCS is going to be making to allow for a 3-bin composting system in the future. And then it's a little hard to see on this upper right photo, but there's a sign that highlights top 10 conservation practices that are urban and small farm focused. Everything from mulching, cover cropping, high tunnels, pest management, low tunnels. So incorporating a lot of the practices that NRCS has made incorporated into technical assistance as well as financial assistance. And then she's been out doing working group trainings and support and delivering fall cover crop seed. There has been a lot of changeover in staff with a lot of the Southwest working groups, so getting new people on board. Also supporting Get the Dirt. And then upcoming to promote our September 4th with a micro irrigation workshop that's at the Southwest Purdue Ag Center, and with a real focus on urban and small scale irrigation featuring NRCS and also Purdue presentations. And then we'll support Technology Days at the Soil Health Trailer on one of those days next week. And I think early September, Women for the Land is doing a discussion leader training. And then she'll also be joining the micro irrigation design training that's geared towards planners on August 26th, which is a 4-day training in Indy, featuring people from NRCS in Texas and other experts. Oh, and here are just a few more photos from the Southwest. Cover crop display also at Pathway to Water Quality in the bottom right, and the micro irrigation workshop flyer, which we'll make sure, I believe it's on our website. If not, it's in our newsletter. And Megan, we'll turn it over to you.
Thanks, Ellie. In the Southeast, I've been extra busy with working groups, with establishing cover crops, with doing workshops, and I've just really enjoyed meeting new people, visiting people I've met previously, and just being a part of the small grower community and the conservation community here in the Southeast of Indiana. A couple weeks ago, we had a really fun event at the Georgetown Optimist Club. We had a pollinator picnic that was kid focused. So we spent a great time playing some games, doing crafts, and IDing plants and their pollinators. I want to give a shout out to Savannah Stout from Quails Forever, Pheasants Forever. She did an amazing job engaging the kids, and she's just a wealth of knowledge. So anytime she's attached to a workshop, I suggest you go and check it out. I collaborated with NRCS and SWCCDs and growers at the Rush Shelby Women's Learning Circle. It was a lovely group of folks, and we had the opportunity to visit Arnold Farm, which is a 200-year-old family farm in Shelby County. And then I had a blast teaching about and planting a variety of cover crops at the Wayne County Soil and Water Conservation District's demonstration garden. We had a great crowd there, lots of really good questions. And just like everybody else, I've been giving away cover crop seeds to anyone who's interested in experimenting. So if you're in the Southeast and you would like to get some cover crops, please let me know. I have them for anyone who's interested. Upcoming events in the Southeast. In Dearborn County, we're doing a cover crop urban beekeeping and pollinator field day on the 16th of August at Bright Meadows Park in Lawrenceburg. Then that next week in Clark County, Yard Sprouts Urban Gardening Workshop, we're going to do cover crops, season extension, and putting your garden to bed. That's from 6 to 8 on the 21st at Endress Lodge in Lapping Park in Clarksville. There's going to be a small ruminant field day with FAMACA certification training from 8 to 3 on Saturday, October 24th in Columbus. And then at the demonstration garden in Muscatatuck Park in Jennings County, we're going to have a cover crop and season extension workshop from 10 to 12. So that event is a hands-on workshop. So we'll be planting cover crops in our demonstration garden and sort of turning over what we have right now into a fall garden, planting things that should live over the winter season and that we can harvest in spring, as well as establishing beds for cover crops to prepare the beds for spring in 2025. Also, just don't forget that now is the time to start thinking about grants and other possible project programs. Late summer and fall are usually the grant deadline period, so start planning those projects that you'd like to get funding for. I know CWI is coming up. It's just around the corner. Don't forget about SARE, Farmer Rancher grants, professional development grants, educator grants, partnership grants, they're all available. So next slide, please. And these are just some flyers for the events that we have coming up for August the 16th, August the 24th, and August the 21st. So if you're in the Southeast or you're interested in learning more about small scale conservation practices, particularly related to season extension, cover crops, and fall and winter gardening, I'd love to see you there. Please reach out if you're interested, both in starting a working group, getting your soils tested, perhaps having an event sponsored by Urban Soil Health or the Soil and Water Conservation District. Happy to help on those things. And so I'll see you guys all out there. Thanks so much.
The only other thing we had is to plug Get the Dirt once more for everyone. Registration is out, and I'll pop the link in the chat. And it will be actually from 8 to 6 on October 16th. We'll have a little bit of buffer time for networking in the morning, and then we have an on-farm social at Porter Farm, which is nearby the Hendricks County Fairgrounds. And just wanted to plug the agenda that has been released and is on the registration list. We have our keynote, who is Lolly Hess, who I'm sure many of you have enjoyed her delicious food at Purdue Small Farms Conference or at other events in the area. And she'll give a presentation as well as cater the lunch. And then we did switch things up this year to have breakout sessions so that there are more options for people to attend and select. We have Invertebrate Soil Life with Dr. Stephanie Frischi with the Xerces Society. We have Integrating Perennials, really focused on both fruit and nut perennials, as well as some of our berries, with Jonas Carpenter of Mavernine Farm in Bloomington. And then Small Farm Agronomy. Keegan Hilaire is with the Rodale Institute and will be able to talk with us even more about soil test interpretation and application. And then Promoting Native and Beneficial Insects with Dr. Laura Ingwell. And then in the afternoon, we have Organic Agriculture with Ashley Adair, Regenerative Homesteading with Bree Ollier. We have, and then a larger session where we'll bring together many of our planners and conservationists for a conservation planning case study, basically how to go from start to finish in an example farm to like walk through that conservation planning process. And then we'll have our social hour at Porter Farm. which is a partnership between a veteran coalition and then Hendricks County Soil and Water Conservation District. So I'll pop that link in the chat, and without anything else from our team at this time, please chime in with anything that you have that you'd like us to know or share out. Or any remaining questions that came up as we move through both our guest presenter and ourselves.
Hey, good morning, everyone. This is Ashley Adair, Extension Organic Ag Specialist at Purdue. I just wanted to throw a plug in for the Midwest Mechanical Weed Control Field Day coming up on September 11th at Miggs Horticulture Research Farm, which is about 20 minutes south of Lafayette. It's a great opportunity for growers in particular to learn more about mechanical weed control technologies and options, whether you're a small farmer using hand tools or two-wheel tractors, or you're a larger scale farmer using four-wheel tractors and larger implements. I'll pop a link in the chat. The cost to attend is $75. Oh, Ellie's got it. The cost to attend is $75. It includes lunch, and the day lasts from about 9 a.m. until 4:30 p.m. and doors open at 8. We will have a trade show, and we encourage you to interact with both Indiana exhibitors, some Purdue exhibitors, like Laura Ingwell will be on site with her Black Soldier Flag composting demonstration. And then we'll also have some regional and national exhibitors as well, in addition to our field day demonstrations where you actually get to see equipment operate in the field. So we're really excited about this. I'm really excited that we've been able to partner with the Land Connection out of Illinois on this event. It's been great to work with them, and I'm really just grateful for the staff at Miggs, Chloe Hinscheid, our farm manager, and the team down there for working on this event with me for the last 9 months or so. If you have any questions about it, don't hesitate to reach out to me via email and check out that link in the chat. Thank you, Ellie.
Yeah, and I'm not sure if they're already reserved, but SARE has, I believe, made an opportunity to cover the registration for a few people. So if the cost is a barrier through your work and you're with the ICP, I think it's appropriate to reach out to either Ashley Adair or myself on that. Julie, would you like to jump in with your Allen County event update?
Absolutely. Good morning, everyone. I'm here with Michaela Cook. She's going to lean in. There we go. We are in Allen County. We're in Terry Theisen's region of your group. And even though some of these events aren't completely sponsored by this, I hope it's okay that we bring to your attention the Upper Wabash Field Day, which is in Huntington on the 27th of August. So about 2 weeks. And then before that, we have Adams County, one of our partners, and they've done a great job down at Gene Whitty's farm. And that is on the 21st. 21st. And this is cool. I wanted to bring it up because in the morning, they're doing a deep dive from 10 to 2 for farmers, producers, soil testing. There's going to be drone imaging that they're going to talk about, part of the education. And then in the afternoon and evening, they've got a more of an open house. And so it's a really cool break apart to reach out into the producer community. And then we, Allen County, have our soil health field day at the Remke family farms on September 4th. And so we just wanted everybody to know about all those. And we're working on a composting field day for late fall with Terry's help and our working group with y'all. And so if anybody's done composting field days, we'd like to get the stink on that.
I love that. Thank you so much, Julie. Yeah, you have some great composters in the Northeast. I keep thinking of St. Joseph County and their citywide compost program, and then I think Dirt Wayne also in Allen County. Thank you so much for sharing. If you have event links, feel free to pop them in the chat. Does anyone else on the call have anything that they would like to share?
I could share a little.
All right.
Community growers in Montgomery County handed out cover crop seeds from Urban Soil Health on this past Saturday. We handed out a lot. I'm all out of everything that's not oats and peas, just because I've got so much of that left. So it's good to hand out some cover crops and help some people experiment. And we're having our next quarterly meeting tomorrow evening at Wally's house. So that's what's going on with community growers right now.
Awesome. Thank you so much, Sam. And it's great to see that people are utilizing those cover crop seeds and you're getting them out early, which will hopefully give them a good chance to get established.
Mm-hmm.
Anyone else have anything? All right. Well, without anything from others, thank you so much for your attention today. I hope it was valuable, and we'll get the slides from Jamie up on our urban updates box and recording up there as well. And then join us next time in early September. Just one second. I don't have the date on here, the second Tuesday of the month in September, and we'll have Sarah Grants with Farmer Rancher, the Farmer Rancher Grant and Youth Educator Grant coordinator, Liz Brownlee, who was formerly with Partners in Food and Farming, and also with Nightfall Farm. So I know many of you know Liz, and it'll be a wonderful time to reconnect with her in this new role. And thank you so much, Julie, for putting those links in the chat. With that, thank you so much, and we'll see you next time.